Okay, this morning while the soldering iron is heating up, I thought I'd go over a couple things. It's mainly for newbies. Getting ready to populate the turret board. This is a standard electrolytic, I can't talk early in the morning, capacitor. You can see the value on it is 25 UF, 25 volt. Pretty standard for what Fender uses on most of their cathode bypass in the preamp. Usually they're going to go with 100K on the plate, 25 on the bypass, and 1.5K on the cathode resistor. This is primarily for newbies. Let me set this down. If I get the damn thing to hold still, maybe we can do it this way. Okay. If you notice, all caps that are electrolytic are supposed to be identified. You can see this bulge right here. That bulge will almost always indicate the positive side of the cap. That's this lead going this way. And if you notice these arrows pointing that direction, it also has a negative sign right there to give you an idea that that end right there is going to be the negative end. It's usually pretty easy if you take a look at these, even if you're a little confused looking at the markings, because the positive end always is going to be coming out of that insulating material like that. Nothing else there, just a straight lead coming out. And almost everyone I've seen, the negative end is going to be soldered on to that lead that's sticking out the back right there. So that's kind of an indication between the two. You don't want to put these in wrong, because if you do, they can smoke or they can explode like a firecracker right in your face and puke all kinds of nasty shit all over your inside of your turret board. So you always have to pay attention to the polarity on these. If you're using one of these for a cathode bypass, the positive is always going to go towards the tube socket and the negative is always going to go towards your negative. Okay. Same thing here. This is a poly. These are excellent caps right here. If I get the damn thing to show. I don't know how you pronounce that, but it's ERO. Eero. This is a 0.1 400 volt. And if you'll notice the stripe right next to my thumbnail, that stripe indicates the negative end when this one's made. If you happen to put one of these in backwards, they're not going to smoke on you because they're made to where they can go either direction. But depending on how the foil was wrapped on the inside of them, they try to put the negative on there to indicate which way this cap will work best in the application. So again, if I'm using this for in a particular application for a bypass cap, I'm going to want this negative side, this band towards the negative side, and this is going to be my positive side right here. If I'm using these on a coupling cap, it's generally recognized that the best way to do this is to turn the band end, this end here, towards the preceding stage. So if this is going to be a coupling cap and your signal's coming out of your plate resistor, and this is hooked onto the plate resistor, you generally want this band pointing towards the sockets. So if this, again, for newbies, if you take a look and you see, like say on this drawing that I've made right here, if I were to put this is the wrong value because this is a 0.1, but that's okay. This is a coupling cap right here. I would install this with the negative end right here. Fingers are not cooperating with the friggin' phone this morning. Towards the end, towards the sockets right there. So that's just another little tip. Make your amp sound better, be less noisy, less overall white noise. Also today, I happen to have some of these, which are really kind of neat. These are the old Ajax caps that Fender had in some of the original amps back in the 60s. I bought an old chassis, and there were several of these in there, and I salvaged them out of the chassis. People that are real cork sniffers about caps just go nuts over them because that's what the original Fenders had. And a lot of unscrupulous techs take them all out so they can have them to use for other amps, and they put in new orange drops and tell the customer that they made their amp a whole lot better. Coupling caps rarely ever leak. Usually they're either good or bad. If they're leaking any DC voltage, then they're bad and you get rid of them. Other than that, they're good and you keep them. You don't want DC voltage going downstream to the next input grid of a preamp tube, because it causes all kinds of bad things to happen to that tube. It can cause, eventually, depending on the amount of voltage, the tube eventually to go into runaway conditions because it affects the bias of the tube itself. These, if I could hold my hand still, I'm going to put I've got my fluke on capacitance. I'm going to hook up a lead on this. This one is got it upside down, 0.1. Let's see what it tests out at. Right on the money. And I can change my range. Point one. One of the other things too, people talk about, you talk about everything that is made electronically is made in large batches. They make a large batch of anything. They shoot for specific tolerance of what they're trying to create. And when the items come out of the batch, depending on how they happen to come out, that's where you'll see the rating of 1% tolerance, 5%, 10%, or 20% tolerance. Okay, these are brand new, these 2525s. I'm going to throw one of those on the tester, and let's just see what it checks out at. It's supposed to be 25, and it is a 29. So you can see the tolerance was not very good on that particular cap right there. Will it hurt for the application I'm using it for? No, not really. But let's check another one. Again, it's all from the same vendor, same batch. And this one is, come on. Let me get on a different range. No, can't read that one. I don't know what I'm doing wrong. Hang on. Trying to three-hand it. Still can't read that one. Kick that one over to the side. Okay. There we go. 26.3. So that's pretty good. That's not far off. Previous one that I tried to measure, 27.5. That's not bad. Let's look at the tolerance on this one since I'm bragging about it. See how damn far off that is. You sound really good. Right on the nuts. And got an old ceramic cap right here. And it's still right on the nuts. One other thing I was going to show you guys real quick. This was an old trick. I'm going to put this back on resistance. This is an old trick that the guy showed me that was in the Navy. This is an old carbon comp resistor. This one's supposed to be 100K. And it reads